Let's take a look at finding the cosine of 17 pi over 6. And in order to do that, we're going to find a reference angle to find the trig function, and then we will apply the sine, the SIGN, to the ratio that we find. So taking a look at our theta here, 17 pi over 6, here's our theta. And this is 17 pi over 6. That 17 is a little illegible there. To get an idea of what we're talking about here with this theta, take a look at the denominator. We're looking at 6. So this is a pi over 6, which implies that for our circle, half of our circle, pi is divided into 6 equal pieces. 1, 2, 3, 4, 5, 6. So half of our circle, half of a revolution, which is pi, 180 degrees, is equivalent to 6 pi over 6, the 6 pieces of the sixth. One complete revolution, our 2 pi, the equivalent fraction for that, using our denominator of 6, is 12 pi over 6. When we look at our theta, cosine 17 pi over 6, the 17 in the numerator is greater than the 12 in the numerator for our 12 pi over 6, which tells us that our theta of 17 pi over 6 includes one complete revolution of 12 pi and then some more. So to take a look at what that means, we will have gone one complete revolution. There's our 12 pi. And then we go 12, 13, 14, 15, 16, 17. So we go there. We know from our work in terminal angles that we could find the angle that has the same terminal side as our 17 pi over 6 by taking our 17 pi over 6 and subtracting out one complete revolution, or 12 pi over 6, to give us 5 pi over 6. So 5 pi over 6 is the angle that we're going to concentrate on. Pulling out a complete revolution, we've gone from here to here. So this represents our theta. Now, in order to find our cosine of 17 pi over 6, we want to find a reference angle that we're going to use. Remember, the reference angle is the acute angle formed by the x-axis and the terminal side of our theta. So here's our x-axis, and here is the terminal side of our theta. So our reference angle, we can call that alpha, is here. Looking at the graph that we have, we can see if this is 5 theta and this is, 5 pi over 5 theta over 5 pi over 6, that our reference angle then here is pi over 6. Again, we could get at that information. We know that the reference angle is the angle formed by our x-axis, which in this case is pi. And then we subtract out our theta, which is 5 pi over 6. In order to do this subtraction, we use the equivalent fraction of 6 pi over 6, and that gives us pi over 6. So again, our reference angle is the pi over 6. Now we can consider, because we're looking for cosine, the cosine of pi over 6. And we know, because we have all diligently memorized the cosine, sine, and tan of 45, 30, and 60-degree angles, that the cosine of pi over 6, the ratio is square root 3 over 2. So that's our ratio, square root 3 over 2. Our final consideration is the sine, the SIGN. The angle that we're looking at is in the second quadrant here. We can use our all students take calculus to help us remember that in the second quadrant, the S, its sine and its reciprocal function cosecant, which are positive, so that cosine is negative in the second quadrant, so that our answer, cosine, is going to include the negative sign, negative square root 3 over 2. Another way that you could remember this is that cosine is x over r. In the case of the unit circle, it's x over 1, or cosine of theta is x. And in the second quadrant, x is negative, so cosine would be negative.